Newton's second law of rotation. Now we are going to consider two variations of Newton's second law. The one which we had earlier done, remember F is equal to ma, that is for linear motion. So a similar expression is valid also for rotational motion. So Newton's second law for linear motion is F net is equal to m into a, where m is the mass, a is the acceleration. And acceleration is the rate of change of velocity. And in formula terms, it is written like delta v upon delta t, where delta v stands for the change in velocity. Delta t is the time taken for that change to happen. Now, what is the corresponding equation for F net is equal to ma? The term analogous to force is torque. The term analogous to m, mass, is moment of inertia. A is linear acceleration. So the term analogous to A will be angular acceleration, that is alpha. Hence, the equation becomes net torque is equal to moment of inertia multiplied by alpha is the angular acceleration. Now, angular acceleration is the rate of change of angular velocity, which in formula terms is written like this. Alpha is delta omega upon delta t, where delta omega stands for the change in the angular velocity. And now let us solve the question based on this principle. So the formula is torque is equal to I alpha. This is the same question which we had done earlier. So we have two balls, 1 kg each, and we have a rod ABC, a horizontal rod. So previously we had found the moment of inertia of this entire system if the axis of rotation is about the point A, and the answer was 0.4 kilograms per meter square. Now, in this case, what we are going to do, let's read. If a force of 100 Newton is applied perpendicular to the rod at point C. So, if we apply a force of 100 Newton, which is perpendicular to the rod as shown, we have to find the angular acceleration for rotation about the point A. Since we have to find the angular acceleration, we are going to use the basic formula torque is equal to I into alpha. F is equal to ma for linear motion, but for rotation we use torque is equal to I into alpha. In this case, rotation is about the axis A, and the moment of inertia we had found out was 0.4. So let us make alpha as the subject first. So alpha angular acceleration about the point A will be equal to torque about the point A divided by moment of inertia about the point A. And the moment of inertia is 0.4 like we calculated earlier. And how do we find the torque? We go back to the basic formula torque is equal to Rf sine theta. Now we need to find the torque due to this force F. So F will be equal to 100. R would mean the distance between the force and the axis of rotation. So which means from the point A till the point C, which is 20 plus 20 plus 20 plus 20, which is 80 centimeters, which can be converted into meters to 0.8 meters. And theta. Theta is the angle between the force and R value. Now the force is perpendicular to the rod, which means theta is 90 degrees. So let's write the formula for torque. It is Rf sine theta. R is 0.8, force is 100, and sine of 90 degrees. And now if we solve this, we will get alpha A as 200. Now, since it is angular acceleration, the unit will be radians per second square. So this is the angular acceleration of the entire body if the axis of rotation is about the point A. Next off, please consider the same system, but the axis of rotation has been changed. Axis is now passing through the point B. Now, this question also we have done earlier, where we found the moment of inertia about the point B, and the answer was 0.08. Now, like in the previous case, here also, let us apply a force of 100 newtons, but perpendicular to the rod at the point C as shown in the figure. We need to find the angular acceleration for rotation about the point P. So we are going to use the same formula torque is equal to I alpha. Let us make alpha as the subject. We will get torque upon moment of inertia. We have to find alpha about the point B, which will be equal to torque about the point B divided by moment of inertia about the point B. Now, the moment of inertia about the point B we had already found as 0.08. So let's write 0.08 in the denominator, and numerator is the torque. And we know the formula for torque is Rf sine theta. So the force is 100 newtons. R would mean the distance between the force and the axis of rotation. So we need the distance between B and C, which is 20 centimeters plus 20 centimeters, which is 40 centimeters, which is 0.4 meters. So let's write down the torque will be R, which is 0.4 multiplied by force, which is 100, multiplied the angle sine theta. Theta is the angle between the force and the R value. This is 90 degrees since the force is perpendicular to the rod. So we will write sine 90. And now if we simplify this expression, we get 500. So 500 is the value and the unit is radians per second square. 500 radians per second square is the angular acceleration of the system if the rotation is about the axis B. Now, this is the most important topic, how to solve questions. So steps to solve questions. So we are going to categorize all questions in three categories: linear motion, rotational motion, and linear plus rotational motion. So consider this figure on the bottom. We have a person which is trying to pull an object upwards using a pulley setup. So this diagram is actually a combination of linear as well as rotational motion. And how is that? So the box is going to go up, which means the box is moving in a straight line, linear movement. On the other hand, the pulley is going to rotate. In this case, it is going to rotate in a clockwise fashion. Hence, pulley is rotating. That is why this is a combination of linear movement as well as rotational motion. Now, let us say if we cut this rope so that the box does not move. So look at this figure. So the string has been cut, so the box cannot move. But imagine that the rope is all coiled around this pulley and the person is trying to pull the string downwards. Then the pulley is going to rotate. Hence, in this case too, there is no linear movement, but there is only rotational motion which is happening for the pulley. So this is the category number two where only rotation is happening, no linear movement is there. Now consider the first category where we only require linear movement to happen and no rotation should happen. And that is only going to happen if the pulley does not have any friction. So have a look at this diagram. If the pulley is frictionless, then the pulley cannot rotate. And why it cannot rotate? The rope, although it is going over the pulley, but for the pulley to rotate, we need some friction between the rope as well as the pulley. If the pulley is frictionless, then the rope will not be able to move the pulley. But the person is still pulling the rope downwards, which means the box is going to go up. Hence, in this case, only linear movement of the box is there and there is no rotation. Why I have shown these three diagrams is because whenever any question is presented to you, you need to figure out which category does it fall under. Is it only linear movement? Is it only rotational movement? Or is it a combination of both? Once you have identified that, then let us see what are the steps involved to solve questions. In category one, step number one is draw the free body diagram. Step number two is then find the net force acting on the object. And the third step, like we have used a lot, F net is equal to ma is the formula to be used. In category two, where only rotation is happening, step one stays the same. Draw the free body diagram where we have to show all the forces acting on the object. Step number two will now be find the net torque acting on the object. And then we use the corresponding formula similar to F net is equal to ma. So for category 2, the step 3 is use the formula net torque is the product of moment of inertia and the angular acceleration. For the last category, which is the combination of linear as well as rotational motion, step 1 stays the same, draw the free body diagram. But in step number 2, we need to find both the net force and the net torque acting on the object. And then we are going to use both formulas separately. F net is equal to ma and torque net is equal to I alpha. So in this figure, box is having the linear movement. So we are going to apply F net is equal to ma only for the box. On the other hand, it is the pulley which is rotating. So we are going to use torque net is equal to I alpha only for the pulley. Now these two formulas are to be used along with a formula which connects linear acceleration with angular acceleration. And the formula is this: A is equal to R alpha. A is the linear acceleration, alpha is the angular acceleration, R is the radius. Let me explain this by zooming in this diagram. So we have a pulley which is rotating in a clockwise fashion. It has an angular acceleration. And how do we draw the arrow of the angular acceleration? Since the pulley is rotating in a clockwise fashion, so we will draw an clockwise arrow. This is the direction in which the pulley is accelerating. But this is angular acceleration. Now, what is linear acceleration? How do we find the linear acceleration? So consider any point which is on the circumference of this pulley. So let me label a point P, which is on the circumference of the pulley. The way to find the linear acceleration is we need to draw a tangent at the point A. So let's draw a tangent to the pulley at the point A. This arrow represents the direction of linear acceleration for the point A. Let me label this arrow with A. A, remember, is the linear acceleration, whereas alpha will be the angular acceleration. So in this case, the distance of the point A from the center, if I draw a dotted line connecting the point under consideration to the center, this distance will be equal to the R value. So R stands for the distance between the point and the pivot point, the point about which the pulley is being rotated. So in the exam questions, please remember F net is equal to ma is to be applied with net torque is equal to I alpha along with the formula which connects the linear acceleration with angular acceleration. But of course, this will be used only in that case where linear movement as well as rotational motion is happening.